Before we begin, I'd like to review the mathematical inverses and identities that you are familiar with. The inverse is something that undoes what you're doing. So in addition, if you want to undo something, you subtract. So subtraction is the inverse of addition. So 3 minus 3 gives us 0. 0 is the identity in addition. In other words, if I have 3 and I add 0 to it, I get my original number 3 back. In multiplication, the operation that undoes multiplication is division. So 4 divided by 4 is 1. 1 is the identity in multiplication. In other words, 4 times 1 is 4. Multiply any number by 1 and you get the original number back. In 4.5, we'll be looking at matrix inverses. In order to find the inverse, we're going to need the identity. So our objectives for today, there are 3 of them. The first objective is to understand and write identity matrices. The second is find multiplicative inverse matrices. And the third is to use the inverse matrix to solve systems of linear equations. You multiply a matrix by the identity matrix, you should get the original matrix back. And that should be commutative. So in other words, for this square matrix, 2 by 2 matrix, to show that the matrix times the identity is the original matrix back, and the identity times the matrix is the matrix back, we take the identity matrix, which is 1, 0, 0, 1, multiply it by our original matrix, and we get A back. So the identity times A is also A. For a square matrix, all across the diagonal, you have 1s, and then everything else is 0s. One of the best tips for success in a math class that I can pass along to you is to work through the examples in a textbook. Working through the textbook examples has multiple benefits to you. Not only are you reviewing the material that you already know, but it also guides you into learning the new material. So to multiply matrix A by I, to find element 1, 1, I need to multiply the first row of A times the first column of I, and then I get negative 2 times 1 plus 4 times 0 plus 0 times 0. To find element 1, 2, negative 2 times 0 plus 4 times 1 plus 0 times 0. Element 2, 3, negative 2 times 0 plus 4 times 0 plus 1 times 0. Element 2, 1, 3 times 1 plus 5 times 0 plus 9 times 0. Element 2, 2, 3 times 0 plus 5 times 1 plus 9 times 0. Element 2, 3, 3 times 0 plus 5 times 0 plus 9 times 1. To find the elements in the third row, 0 times 1 plus 8 times 0 plus negative 6 times 0. 0 times 0 plus 8 times 1 plus negative 6 times 0. And our final element, 0 times 0 plus 8 times 0 plus negative 6 times 1. After each textbook example, they recommend one of the exercises for you. The answers to these are in the back of the book. Let A equal this 2 by 2 matrix. Give the 2 by 2 identity and show that A times I equals A. So we need to and then my identity matrix is this. And then when we multiply, 4 times 1 plus negative 2 times 0, 4 times 0 plus negative 2 times 1, 3 times 1 plus 1 times 0, 3 times 0 plus 1 times 1. We are cautioned here that although the inverse of A equals 1 over A for any non-zero real number, if the matrix A has an inverse that is not equal to 1 divided by matrix A. In fact, 1 divided by the matrix A has no meaning, since 1 is a number and A is a matrix. They're two different things. To find an inverse, here's the steps, and you can read through and work through example 2 in your book. To keep this video short, I am going to go ahead and do exercise 15 now. Number 15 asks us to find the inverse of matrix A if A is this 3 by 3. So my first step is to write the augmented matrix with the identity. Then I'm going to take the opposite of row 1. Pretty much you're just performing the system's methods for elimination to change this first left side, the left 3 by 3, to look like the identity. And then the right side will be your inverse. So the opposite of 2 times row 1 is negative 2, 0, negative 2, negative 2, 0, 0. And then row 3 is 2, 1, 1, 0, 0, 1. And when I combine those, when I add those together now, I get 0, 1, negative 1, negative 2, 0, 1. So now I can replace this with this third row, because remember my goal is to just have ones across the diagonal and everything else being zeros. So this has a 0. So I'm going to do that. And yes, when you do this on an assessment or for your homework, you do need to write this all out if you want full credit. So now I can take row 2 plus row 3 and add those. And then I can take the opposite of that, and now I have 0, 0, 1, so I'm going to replace that with row 3. And I'm going to change the signs on this row right away. So now the only thing I have to eliminate is this 1 right here. So what I'm going to do is take row 1 and subtract row 3. And now I can go ahead and substitute that in for my row 1. And now this side, the left side, looks like the identity. Then this side here is my inverse. It's important to point out that not every matrix has an inverse. Sometimes you just can't reduce this to the identity. For example, this would be an example of that. And if you look up here, you can see that if I divided this first row by 2, I'd get the second row. So there's no situation where x could equal 1, y would equal 0, and also x could equal 0 and y would equal 1. So that's why that doesn't work. By the way, pay attention to figure 12 in your book. Using inverse matrices to solve linear equations. So, in your book, they remind you how you write a matrix, and then they walk you through setting up one. I think I'm just going to jump in, for the sake of time, to exercise 25. The directions for 25 read, solve each system by using the inverse of the coefficient matrix. So to begin with, I'm going to define that coefficient matrix using the coefficients of x and y. I'm defining the variable matrix with x and y. And then I'll define matrix B with the constants. So to find the inverse of matrix A, I want to use matrix A augmented with the identity matrix. Now, if I take 1/2 of row 1, I get 1, negative 1/2, 1/2, 0, and then I'm going to substitute that in here. Then I want negative 3 times row 1 plus row 2. We need the opposite, so I need to change that sign. and then negative 3/2 in 0. And then row 2 is 3, 1, 0, 1. When I add these, my x coefficients are eliminated. 1 is the same as 2/2. So when I add that, I get 5/2, negative 3/2, and 1. Now, I would like for this number here to be a 1. In order to convert that to a 1, I'm going to multiply this row by 2/5. The 2 divided by 2 reduces. So now I have the reduced echelon form, or row echelon form, I should say, of matrix A as and it's a little more than just matrix A because I put the identity. It's augmented. So that's the augmented A. So now this is what I'm working with. All I need to do is eliminate this 1/2 right here, this negative 1/2. So in order to do that, I'm going to take 1/2 of row 2 and then add it to row 1. And when I do that, I get, oops, my fault, looked ahead at the wrong row. So another way to rewrite 1/2 with the common denominator is 5/10. So then I have 2/10, which reduces then to 1/5, and 2/10 here plus 0 reduces to 1/5 as well. Now I can replace this with row 1. I'll write it over here so I can see both. It's a 3. Remember, this was augmented. So now this right-hand side is my inverse, because here's my identity. So that means to solve, I'm going to take my inverse matrix and multiply it by the coefficient matrix, which was B, -8 and -2. And remember, when I'm multiplying a 2 by 2 with a 2 by 1, it is possible my resulting matrix will be a 2 by 1. So my first element, 1/5 times -8 is -8/5. Add that to 1/5 times negative 2 is negative 2/5. And I know this is a 2 by 1, so I can close that there. That's going to give me negative 10/5, which is negative 2. Now I want to multiply the second row by the first column to find element 2, 1. So negative 3 times negative 8 is positive 24/5. And positive 2 times negative 2 is negative 4/5. And when I combine those, I get 20 divided by 5, which is 4. Therefore, my solution set is the ordered pair negative 2, 4. If you found this video helpful, please like and subscribe. Smash that like button. You know you wanna. Come on, give it a thumbs up.